Hello, everyone. Finally, we are getting to chapter 3. So chapter 3 is about descriptive statistic, right? So it's one of a branch of statistic, right? So we say that statistic is the science of collecting data, organizing data, analyzing data, interpreting data, right? Interpreting data, right? Then we have two types of statistic. So one is a descriptive statistic, other one is inferential statistic, right? So chapter 3, it's about descriptive statistics. Descriptive statistic, right? So like a word, describe about the statistic. How? Make a table. So we learned that how to make a table earlier, right? And graph. We know how to graph in the previous section, right? And numerical summary, right? So numerical summary we are going to learn in chapter 3, okay? All right. So in this case, organize and summarizing the information. So information means data, right? We knew that. So we are going to learn the quantitative. So quantitative, which is number related, counting, and measurement, right? Okay. So 3.1, we have measures of center. Center, where's the center? I'm the middle center, right? So measure of center. So learning objective. We want to describe, calculate arithmetic mean from the data. Mean, which is average, right? And median, which is middle number. We are going to get to that. And interpret mean, median, sensitive, resistant, sensitive, and resistant, and describe the model from the data. Okay, so let's go over that. Okay, so we have definition. We did a parameter, right? What is parameter? The number based on population, right? What is a statistic? Number based on sample, right? Number based on sample data. Okay, we have a mean, which is average, right? So mean is average. Then population data first, which is population mean. So we knew that in math, when we express general formula, we are using the letters, right? So we call the variables, right? So we have x of 1, x of 2, x of 3, which is data, right? Okay, now we add everything up. So we call this is index, like a subscription, right? Hold on one second. The spell. Subscription. That's the P, right? Subscription. Yeah. Okay. Now we have uppercase of N. We talked before. So when we are using uppercase of N, that means population, right? So population. So basically population size. Okay, now we have this symbol, right? Highlighted with a yellow. That symbol we called in Greek letter sigma. So, oh, there we go. The symbol, this one is a capital sigma, means that uppercase sigma in Greek letter, in Greek. Uppercase means, capital means uppercase. Okay, for your information, what about the lowercase of sigma in Greek letter, right? So sigma. This is a lowercase sigma. So we're gonna learn this one later in Greek later. Okay. In mathematics, we have this symbol. It's summation. Mm. So summation, we can notice that it's a sum, right? Means that we add everything up. This way, look, each data set, we add everything up. It depends on how many data set there. Since it's a population mean, if we want to survey the whole company, the company has 300 employees, right? Then there will be 300, right? Yeah. And then look, we have another symbol here. We pronounce, this is also in Greek letter. So we call the mu. Mu, this is mu. Yeah, mu. Like a cow, cow sounds. Mu, mu. Okay, so we understand everything. So basically, we know how to take the average, right? How to calculate the average, right? We add everything up, divide by number of the data set, number of observation, number of items, right? Yeah, same as here. We add everything up, divided by the population size in that case, yeah? And then we make a symbol. What is the population? Mu, right? Okay. All right, good. Now, sample mean. Sample mean, we have the same formula here. Means that we add everything up, divide by the size of sample, right? So we have a lowercase n in alphabet, right? So that's the sample size. Uppercase n, population size. So sample size. And then let's take a look their symbol. They're using X bar. So we read X bar. So X, oops, we have X, and then there is bar on the top, right? So we called X bar. Okay. Sample mean, they say that it's used to approximate the value of population mean, right? Yeah, even though we have a population mean, if we have a company small enough to get the population mean, we can do that, right? Yeah. But then huge company, more than 1,000. That's huge, right? Then we take the sample mean, right? So we want to estimate the population mean, right? Yeah. That sample mean represents as population mean, right? That's inferential statistic. Okay. Now, we want to calculate. All right, so sounds like this is treated as a population. They say that, right? So population. And uh, we want to know about the population mean. Okay, let's write down the formula first. The formula has, how do we read? Very good. Mu. So mu, yeah, writing out this way is Greek letter. Then let's using, in that case, let me show you. This is x of 1 subscription, right? So what this mean, I want to show that. What's x1, x of 2, x of 3, x of 4, each item, each score will be like that, right? So let me show you x of 1, x of 2, we add them by the formula, right? That's how we express. Yeah. In that case, only 5 items, but they say that we treat them as a population, right? So divided by n, right? Population size, in that case, is 5. And then we have 70 plus 95 plus 80 plus 83 plus 82. Now your turn. What's the numerator? Thank you. It's a 410 divided by 5. Okay, can you please calculate? Thank you, 82. Good job. Yeah, okay. Let's move on. So in that case, we have more, right? So we have Derek, Marshawn, Isabel, Sophia, Juan, right? But then we have a Jackson, Carol. Yeah. One person makeup was not good, and then one person did not take the exam, right? Okay, so we have 7 people, still population. So let's do it. Okay, now mu equal to, we had a 410, right? And then add 10 plus 0. We don't have to add 0 in the addition, right? So 0. Well, if we want, we can just to show that we added 2 more people there. Okay, the n is 7, right? So we have a 7 there because we had a 5. Yeah. So what do you get? 420 over 7. Can you please calculate? 60. Yeah. Okay. The population mean dropped from 82 to 60, right? Yeah. Because 2 students' score was not good, right? So way below, right? So 0, 10, almost 10 is almost 0, right? So we got that. Yeah. So what is telling us? They telling us, hold on 1 second, they telling us sensitive. I cannot find. The mean is sensitive to extreme observation. Let me just writing out here because I cannot find. Okay, I wrote down here, mean is sensitive to extreme observation. Means that, like earlier, if the score is too low, then mean change to lower grade, lower score, right? And think opposite way. What if the score was the bigger number, right? Then the mean will be increasing. Make sense? All right. That means that extreme observation. Yeah. So means uh, higher or lower. Very higher, very lower data. Then mean is also going to lower or higher. Yeah. Okay. Now, so we understand the mean, right? So in that case, mean dot plot, they show us. And then this is the second one. Yeah. And then here is the first one, 82, right? And this is the 60 second one. Okay, now we have a median. So median is middle number from the data set. Median, middle number, the data set. Okay, but then in the data set, we have to make ascending order. Ascending order means smallest to largest data set. Okay. So median, middle number. So here. All right. Now we want to find the median in the case, but then there is a strategy how to find the median. So let's take a look. Number one, arrange the data in ascending order because the definition of median is a middle number in ascending order data, right? Okay. Now, we can just using lowercase n, whether sample or population. Yeah. Okay. Number of observations, number of data set, how many data set we can distinguish. We can count whether odd or even, right? So odd means odd, 1, 3, 5. Even number 2, 4, 6. Yeah. More, etc. etc. Okay. Then when the data set is odd, then we make even. How? N plus 1 over 2. Yeah. So n plus 1, we make an even number. If n is odd, then divide by 2. If we make even, we can easily to divide by 2, right? Okay. That is one. All right. What if the data set is even, then the middle number will be n over 2, since the observation, the data set is the even number, it's easily to divide by 2. So the location between n over 2, then we just add 1 from the n over 2. Make sense? And then can you see the difference between n plus 1 over 2 and n over 2 plus 1? Can you see difference between here? because we have to calculate this one first and then divide the 2 later. This one, we have to do n over 2 first, then we add 1 later, yeah? By order of operation. Make sense? Okay. All right. So n over 2 plus 1 position will be middle number. Yeah. N over 1 over 2 position. So location, same thing. Location, position, right? Will be middle number, right? The position, the spot. Then we can find the middle number. Yeah. Make sense? All right. So let me show you how to use by hand, how to use by hand, how to do by hand, and then I'm gonna show you how to use the second. All right. Okay. So the we have a smaller data set, so easily to find the median without using formula. Yeah, but then think about this. What if we have a lot of data set, right? Yeah. So we need to practice how to do by hand first with the easy smaller data set. Then we can apply to the large data set, right? Okay, let's do table number 1. Table 1. Hold on 1 second. Okay, so table 1. How about median for table 1, right? Okay, median for. All right, so we have to make ascending order first, right? So 80, 82, 83, I'm sorry, 70, missing 70, 95, yeah? Okay, 5, right? Okay, now n equal to 5, which is odd. Then we make a even number in order to divide by 2, right? So n plus 1 over 2, which is 5 plus 1 over 2, which is 6 over 2, which is 3. Third position, location, yeah. Okay, that will be 1, 2, 3, 82, right? So let's say using median symbol, like a first letter M. So M will be 82. Yeah. Okay, how about table 2? So table 2 has, they add like a Jackson and Carroll like earlier, right? So one student take the makeup exam, but was not get one, did not take the exam, right? So median for table 2. So then 0 first, then 10 second, right? 70, 80, 82, 83, 95. Yeah. Okay. So n is changed as 7. So we cannot use it like earlier, right? So n equal to 5. So we have n equal to 7 now. Still odd. Then we make it even in order to divide by 2. That is 7 plus 1 over 2. That's 8 over 2, which is the fourth position, location, right? Okay, which one is Let me write down location. 1, 2, 3, 4. So that is the fourth. So m equal to 80. Okay, so even though we add very lower score, Jackson 10, Carol 0, right? Looking at the median was not changing much, unlike mean earlier, right? So mean, the first one had 80, and the second one, if we add Jackson 10 and then Carol 0, we had 60. There is 20 gaps, 20 score gap, right? But median, look, 80 to 80, not much change, right? So the mean earlier, very sensitive for the extreme observation, right? How about the median? How do you say, right? So we can say that median is resistant. What does mean? Resistant. So median is resistant to extreme observation. So extreme observation means very lower score, very lower data, or very high data, right? So meaning it is not greatly affected by extreme data values. For this reason, the median is a better measure of center when there are extreme values in the data. Okay? So if there is very low score data, if there is a very high score data, then it's good for using median as the center. Make sense? Okay, so we have 6 observations, 6 data set. And also I brought the that strategy, yeah, guardians here. Okay, okay, let's do that. Is it ascending order? No. Okay, then we have to make ascending order. There will be 10, 11, 14, 16, 19 twice, yeah? Okay, 6, yeah? So n equal to 6. All right, it's an even number. Then we following second part, right? So even then the median will be the location n plus, sorry, n over 2, and n over 2 plus 1 position, right? Location. There will be n equal to 6, so 6 over 2, and 6 over 2 plus 1, that is a third, and fourth, right? No need to calculate, just a fourth, because we had 1, right? Okay, now third and fourth will be here, right? Third and fourth. Then how do we find middle number between 14 and 16? Very good. We add it together, divide by 2, because we want to find the average of 2 number, right? In that case. All right, so let's do it. Okay, so there will be m equal to 14 plus 16 divided by 2. Can you please calculate 30 over 2, which is 15? Excellent. So median for this quiz score, middle number will be 15. Why we are doing this? Yeah, we want to find the middle number, right? Yeah. So in the measure of center, we learned whether mean and median, right? So median is good for if there is a lot of lower score, lower data, or a lot of higher score, higher data set, right? That is good for median. Otherwise, mean is good for, right? Okay. In the case, yeah, just okay. So we can use mean as median, mean as what is called mean as center over center measure over center. Okay, now StatCrunch. All right, what kind the data will be good? Okay, I will follow the textbook here. So let's see. Textbook, we have the number of spam phone calls. And then, let me see, I can copy and paste or not. Okay, so let me show you the StatCrunch, mean and median, all right? All right. Well, let me close it here. Repeat. And screen. Sorry. Okay. Then they say that if we have a whole number, then the answer must be one decimal places. If we have one decimal places, then the original data set one decimal, then we have to answer two decimal places. That's how round in the case. Yeah. So if there is a 3.125, then the original data set whole number, so we keep that 3.1. So we keep the 2.5, one decimal places. Yeah. Okay, now we have a mode. So what is mode? So we learn mean, median. Now this time is mode. So mode is most frequency, right? So occurs most often. That's the mode. All right. We have a bimodal. That means two model, two modes, right? So bimodal, so two modes. And multimodal, then more than two modes, right? Mode. And there's no mode, right? Nothing there, then there's mode, non-mode. Okay, so we have table 3. Find mode for the number of spam calls in table 3, right? So what do you think? What is the most frequency? One? One is the most frequency? Okay, let's take a look at one then. How many one? 1, 2, 3, 4, 5, 6. So mode is 1. Six, 6 frequencies. Yeah. Okay. All right. So I just showed you how to use stack runs. I hope that part of recording, yeah, a little bit confusing for me right now, whether recorded or not. Okay, now recording. Okay, so we have the answer here, right? So mean 55.47, mode is multiple mode, and the median is 55, right? Okay, let's take a look. Histogram from the textbook. So this is mode. And put around 51, right? So a lot of people had a 51. Yeah, I can see the 51, 351, 4. Okay. Now, median is the 55, mean is 55.47, right? So we learned the distribution. What do you think about this one? Is it bell shape or skewed left or uniform or skewed right? Yeah, it's a slightly little bit skewed right, right? Skewed right. Yeah, slightly skewed right. Yeah. Slightly. And then they said that this histogram is bell shaped with a very slight skew. Yeah. Um, we will talk about more about skewed right, skewed left, and how we determine, right? Okay, so in that case, mean is more toward to the right. So we can say the skewed right. Yeah, just a little bit, slightly, slightly skewed. Cause the mean to be slightly larger than median, but not too much, yeah? Okay, so it's not 56, 57, yeah. 55.47, little bit, tiny much, yeah? Okay, let's take a look at this one. When data are symmetric, specifically bell shape or uniform, we use the mean to measure center of data distribution, right? So we had, if we have a lot of data set, lower data set, or upper data set, higher data set, right? Then we are using median because median does not change. Median does not change what this means. Median is resistant, right? So it's good for we having median as center of measure of center, right? Yeah, since we are using that, mean is good for bell shape, uniform, symmetry. Yeah, make sense? All right, good. Okay, so we have a skewed left, skewed right, and bell shape here. Let's take a look. Uh, Median is the middle number, right? So it's about here. But then if we have a skewed left, there is a lower data exists, right? That's why we have a skewed left, right? Okay. So if we have more lower data, then mean was changed there. Remember? Yeah. So mean is the less than median there. And then in that case, this histogram This is the highest frequency, right? That's why mode is here. Okay, let's take a look. Bell shape or symmetric, right? So we can see the mode here because most frequency for the histogram. Median is a middle number, so it's about here. And since this is a bell shape, mean is about in the center too. Okay, let's take a look skewed right. Most frequency, so this is mode. And median is a middle number, so it's about here. Look, we have, since the right side, right? So more highest, higher numbers, higher data see here, right? Okay, if we have a higher number, the mean was sensitive about the extreme observation, right? So if we have higher data, higher data, yeah, the number is higher, right? Then mean change that. So mean is bigger than median. Can you see that, right? Okay, so we learned that, right? We learned skewed left, skewed right. It's good for we reporting center as a median, right? So this is a median is good for center. Why? Because median is resistant, right? So resistant means even though we add extremely large number or smaller number, resistant, it does not change that, right? Much. So, resistant, yeah, median. But the mean was sensitive, right? So in the bell shape, we are using mean as a center. So mean as a center for the bell shape. Yeah. Okay. Good. Okay, let's take a look at this one. Which of the measures of a center is best? We already talked, right? All right. So they talk about qualitative, quantitative, must be quantitative, right? So quantitative, then is it skewed right, skewed left? Then yes, then median. No, then mean, right? So in the case is uh, what is called bell shaped, bell, bell shaped, right? Bell shaped. Okay, if we have a qualitative, right? So we can use mode, right? Yeah. We can use mode. The mode can, if we have a quantitative, there is also mode, right? It's not only the qualitative. We had experience earlier, right? So we had a bunch of number. What was the mode? Number one was the mode. Remember? Yeah. But then if there is a qualitative, we can report mode. Why? Because there is no median. There is no mean, right? Because there is no number, right? Median, mean for only the quantitative variable, right? Yeah. Make sense? All right. Okay, let's take a look at this one. We have a question, number 10. They say that which measure of mean, median, and mode is best? All right. The price of a home in the US are known to skewed. Yeah? What do you think? Skewed left or skewed right? It's skewed right, right? Because there is a so looking at this skew to right, there is too expensive houses right side, right? Yeah, skew to right. So think about that. So skew to right. Skew to right. Seems expensive houses. Okay. What is the best measure of a center for home price? So since it's skewed, right? We can use center as a median, right? And let me write down median. Median is good for center, right? Since skewed, right? And which is larger in the case, the mean or median? So we knew that median is a middle number, so there you go. And then skewed right, so mean is over here, right? So mean is bigger. Yeah. All right, let's take a look. We have a table, right? And we want to know about the histogram. Let's using second. And then it depends on histogram, right? It's a bell shape. Then mean is good for center. Skew to left, skew to right. Median is good for center, right? So let's do that. Hold on 1 second. I want to using that, right? So share screen. Okay, by second, we can see the bell shape earlier, right? So by second, the histogram, bell shape. Okay, then we can report as measure of the center is mean, right? As a center. And then which one is bigger? They are same, approximately same, right? So mean and median and mean and median approximately same. Oh, okay. Uh, so we have to use a second for mean and median. All right, so one more time. Okay, so we are done for this section. I want to bring that histogram. Maybe, is it here, histogram? Yeah, here we go. Yeah, here is the histogram. Yeah. Okay, then let me arrange this one. I can put the mean and median here. Yeah. So let me see that. Uh, Median 11.5 with the red. So Okay, let me do it. Okay, so we have a bin is 2.5. So in the middle is 11.25. So I put median is here with 11.5 and mean is 12.3. Okay. We done for 3.1. Thank you for watching. I will see you in the next section. Thank you. Bye.